Good morning everyone. I am Sangeeta Priya B from the Department of CSE IoT working in SNS College of Technology, Coimbatore. In previous sessions we see about generative models, generative AI and generative models. In this unit 3 we are going to discuss about generative adversarial network, that is GNA, and flow based model. Actually, what is generative adversarial network? Simply we are calling it as a GAN. That is, it's used to create a false data but dictate to the same data which we applied. So no one can find out that the data is a fake or a real. So how we are doing it? We are going to see it in the brief descriptions. The first one is it helps the machines to create a new realistic data by learning from existing examples. First, it was introduced by Lane Goodfellow and his team in 2014, and they have transformed how computers generate images, videos, music, and more. Unlike traditional models, they only recognize or classify data. They take a creative way by generating entirely new content that closely resembles the real world data. The ability helped various fields such as art, gaming, healthcare, and the data science. It is the architecture of generative AI. That is, the first one is we are giving a random input, and in that that passes to the generator. Then it creates the fake image. The fake images is then passes through the discriminator, but we are giving there the real images also. There it will be, discriminators will tell it as real or fake. Now our task is to create a image or a music or a voice that discriminator cannot be find out that the data is fake by using the generators. The first one is how this GAN works. Generator creates a fake data. Here the generator is used to create a fake data. Example, if I am going to have my images that should be created as a fake, then I will be giving it the input to the generated data from the random noise. Then the discriminator evaluates the data. The discriminators compares the fake data with real data and tries to distinguish them. Next one is feedback loop. Based upon the discriminator feedback, the generator adjusts and improves the fake data and process repeats. The next one is generative model. The generator is deep neural networks that take random noise as an input to generate the realistic data samples like images or text. It learns the underlying pattern by adjusting its internal parameter during the training through backpropagation. Its objective is to produce sample that discriminators classifies as a real. The generator loses the function, that is, the generator tries to minimize the loss. Here what we are meaning in the loss is to create a fake data where the discriminator cannot be identified that the data is fake. For this we uses a formula, that is J of G equal to minus 1 by M summation log D of G of Gi, where Jg is measures how the generator is fooling the discriminator. G of Zi is a generated sample from random noise Zi. Then D of G of Zi is discriminator estimated probability that generate sample is real. Next one is generator aims to maximize, that meaning it wants the discriminator to classify the fake data as a real. Next one is discriminator model. The discriminator acts as a binary classifier, helps in distribution between the real and generated data. It learns to improve its classification ability to training, refining its parameter to detect fake samples more accurately. When dealing with image data, the discriminator uses convolution layer or other relevant architecture which helps to extract the feature and enhance the model ability. The discriminator loss function tries to minimize the loss. The formula is J of D equal to minus 1 by M summation log D of Xi minus 1 by M summation log of 1 minus D of Z G of Zi. Here JD measures how well the discriminator classifies real or fake sample. Xi is a real data sample. G of Zi is a fake sample from the generator. D of Xi is a discriminator probability of Xi is real. Then D of G of Zi is discriminator probability that fake sample is real. The discriminator want to correct the classify real data are real. Log of D of Zi and fake data as a fake, that is minimize log of -1 D of Z of Zi. The minimax losses used by this formula we can discuss it in later video. Thank you.